That's great. Okay, so we'll go ahead and get started here. Thank you all for being here. We're going to talk about a new antibody specificity testing service we're going to be offering through Arkion here in the short term, hopefully. Real quick, some introductions. So first, Michelle Tollefson. She's our business and marketing director. Any business questions, go to her. I'm Shawn Jones. I'm process and development manager at Arkion Life Sciences. So I oversee the production of our IGY support product and also all of the R&D on it. And this is Dr. Shawn Wesener. He's with director of R&D at Biotechnical Resources. And he'll be giving the second half of the talk, and he'll give his introduction then. Just real quick about me. I have a Ph.D. in chemical engineering. My background is more in molecular biology and microbiology. I've kind of been a slow transition to the animal health industry. So come at this from not an animal health perspective, but more from a microbiology, molecular biology point of view. And I've been with Arkion for about 4 years now. So first, Arkion, maybe not a name everyone's familiar with. So we are a fairly small company of 40 employees, about 40 employees total. We're headquartered in Newcastle, Delaware. So we're an old DuPont Conagra spinoff of a joint venture. That's why we're in Delaware. We've been a supplier to the egg antibody product in the market for over 20 years. Most of that time, it's been a private label. But in 2021, we launched our own product, this EgTech-C. So it's our own brand of the IGY product. And it's a very diversified business. So within Arkion, we have different products. So the IGY product itself is let me see, this EgCel product here. We also have BTR, so that's where Shane's from. They traditionally do contract research, kind of fermentation, bacterial engineering. We also have this AvaPel product and flight control. This is a bird repellent product. So it's a product you spray on turf or on a seed product that will repel birds from eating the seed or the grass. So it's a non-lethal way to repel birds from where you don't want them. And then we do have Stop the Bites and the AFTS for horses. This is both of these are an insecticide product. It's fully natural, so it's just essential oils. So it's another natural insecticide. So all these products in general have it's all a natural products. So everything we do is something we take from nature and apply it to an agricultural or livestock setting. So that's kind of the one thing that kind of holds all of Arkion together. So I'm going to start off today with a non-controversial topic is the importance of colostrum. I think we all know colostrum is very, very important for calves. They're born immunologically naive, meaning that they don't have an active immune system to fight off specific pathogens. So how do they get these pathogens? So once the calf is born, all these pathogens assault the calf. So how do we protect the calf from these pathogens when it doesn't have an active immune system itself? We all know this is from colostrum. This is maternal passive immunity. The dam makes all the antibodies herself, puts them into the colostrum. You feed the colostrum to the calf, and the calf gets the antibodies from the mother, and it gets some protection from that. But really, what impacts this quality of colostrum? We always talk about colostrum is very, very important for the calf, but how do we judge the quality of the colostrum? And there's a lot that goes into this. It's the genotype, parity, nutrition of the mother, her vaccination status, the birth site, the cleanliness of this, how much colostrum the calf gets, when the calf gets this colostrum. These are all factors that go into this, and it's very, very important colostrum. But then how do we measure this colostrum quality? There's a lot of stuff that go into this. So how do we measure how good this colostrum is? And the primary metric is just total IgG. If you're over 50 milligrams per mil of total IgG, you're good. In this one paper from 2012, we're seeing that about a third of the colostrum in the US doesn't even meet this standard. So a third of the colostrum that's being fed to the calves doesn't even meet this minimum standard, we say, of 50 milligrams per gram of IgG. Other colostrum, it does have higher than, but again, this is all just total IgG, just the total amount of IgG you're giving to the calf. Now, how do we measure the success of passive immunity? Again, it's by the total IgG count. By the old metric, if you're over 10 grams per liter, you're good. If you're under 10 grams per liter, you're not good. A new metric in 2020 went from excellent, good, fair, and poor. But again, if you're under 10, you're poor. If you're over 10, there's different ways of grading that. But again, it's all about just total IgG. How much total IgG is a calf getting? Now, if we look at actually antibodies, antibodies are specific. You may have heard a lock and key mechanism before for antibodies. So what you see here is there's 4 colored antigens here. The antibody itself can only recognize the yellow antigen. So let's say that yellow antigen is E. coli K99. So this antibody will bind to E. coli K99 and neutralize that bacteria. Let's say the purple there is rotavirus. This antibody can't do anything against rotavirus. Let's say the green is coronavirus. It can't do anything against coronavirus. So this one antibody can only attack one specific pathogen. So if you look at the total IgG, you're not really getting this specificity of the antibody. You're just measuring all the antibodies there. But do you have antibodies against all the diseases present in your herd that you need to protect? So these is a sample of 2 different colostrums that we got and tested. So you can see through rotavirus, coronavirus, crypto, E. coli, perfringens, they're all fairly similar. I didn't do any p-value evaluation here, but if you look at the error bars, they're probably about equivalent. But when you look at Salmonella, Typhimurium, Dublin, Heidelberg, sample A has much higher titers than sample B. So if you know you have a Salmonella problem with your herd, sample A colostrum would be probably better for your herd than sample B colostrum. But on the packaging, you have no idea about this. It just says the total IgG. You have no idea what those IgG actually has specificity for. You just know it has total. So sample A and sample B may have the same total, but we see they have different specificities, and so it's going to have a different effect on your calf and the calf health. So that's where we see this need for the specificity service. There's very much a kind of black box of what these colostrum contains. We know it contains IgG, but what kind of IgG does it contain? And that's important for the calf health. So we feed the colostrum to give the calf the antibodies. Those antibodies are absorbed and slowly given off on the calf for protection. But the active immune system still isn't fully operational here. So there's still kind of that gap where the calf is vulnerable. There are other forms of passive immunity. There's diluted colostrum, transition milk, there's plasma, there's whey, and there's spray-dried egg powder. So all of these can add passive immunity to the calf. So if your colostrum isn't good enough, they can add more of these antibodies to kind of get your calf over that first disease period. But just like colostrum, all of these are not quite the same. So this is a sample of 5 different milk replacers that we got, and again, tested for specificity. The brands are listed here. They were randomized, so the sample A through E and that list have no correlation. Our point is not to look at different companies, but just kind of the trends of what we see. We can see here, between these 5 milk replacers, a very large range of specificity. Sample E being very good, sample B being not very good. So again, every milk replacer is not created equal as far as IgG. Even with egg powders, if you look at them, so this is EgTech-C is our product itself. Here's our other whole egg products. Importantly, these are all 100% egg products. Again, you can see very different specificities. So again, just by grabbing an egg product doesn't mean you have the full protection you need from all the disease challenges. And even between things, so this is a sample between bovine plasma and our EgTech-C product. Again, you see EgTech-C has much better protection against E. coli than the plasma. So even different products have different specificities. So it's really, as a producer, you can grab these different products and hope they treat your calf, keep your calf healthy, or you can have this information for yourself. So that's really kind of, we see the need for the specificity testing, is that the total IgG doesn't really give you the whole picture of the story. You really need to know what specific antibodies you have, because that will then tell you what disease you can actually treat on the farm. And so this is what we're launching here. So this is going to go through the Arkion, but it's going to be a collaboration between our EgCel and the BTR divisions within Arkion. So we're going to work together to get this testing going. That's why Shane is here to go over now the BTR component of that and kind of go into more of the specifics of the test itself.
All right. Hi, everybody. So my name is Shane, and yes, I'm from BTR. BTR is a division of Arkion Life Sciences. We're located in Manitowoc, Wisconsin, and I've been there for about 4 years, I'm the Director of Research and Development. My background is in microbiology. I've got a doctorate in microbiology and strain engineering. So our services historically have been in strain engineering and precision fermentation. So we work with a lot of pharmaceutical companies and biotech companies, and we develop a lot of products for them. We also develop what we call bioprocesses. This is a fermentation process to optimize the production of key, key products, whether it's a protein, an enzyme, or maybe a natural product like an antibiotic. We do strain engineering for bacteria. We focus mainly on secretion systems because the downstream processing, the purification is much easier. But we work with things like Bacillus subtilis, E. coli, Saccharomyces, Pichia. So there's some yeast that are in there that we do strain engineering with. And then we also work with strain engineering of filamentous fungi, mainly Trichoderma ricei. And on the microbial process development and downstream process, like I said, we do precision fermentation. So that's like fermentation optimization. So think of like brewing beer. That's fermentation, right? So we actually have a history in the beer market, and we've evolved into the biotech field doing industrial fermentations. And then we do downstream processing. So we have spray drying, we have freeze drying, we also have ultrafiltration, tangential flow filtration, diafiltration, and so we can work on a number of these different levels to develop a process for purification as well. And so we're developing this assay, kind of building off of what Dr. Jones has been working on over at EgCel. And our facility does a lot of analytical work. So we do a number of assays for antibodies, for protein. We have a full analytical suite that allows us to quantify using some other techniques like HPLC and those kind of techniques to get a very accurate measurement of IgG levels. And then we also do a lot of, like I said, bioprocess development. We can handle biosafety level 1 and biosafety level 2 organisms. And then we also have a lot of molecular analytical offerings too. So as we're developing this assay, we're looking at a number of different samples to analyze, including colostrum, both liquid and the dried powder colostrums, colostrum replacers, and then milk and transition milk or waste milk, so both liquid or dried powder, and then milk replacers. And so we're looking at developing a kind of a high throughput system so that we can standardize the purification of the IgG from each of these types of samples so that we can have a very accurate comparison between, whether it's between liquid colostrums and then also maybe a dried powder colostrum. And the pathogens that we are developing testing for are going to be bovine rotavirus, bovine coronavirus, E. coli K99. We've got antigens for a few other E. coli too. Clostridium perfringens type A and C and D, Salmonella typhimurium and Salmonella Dublin, and then Cryptosporidium parvum. And so many of these are associated with scours and infections that occur like right within those first 20 days of life. And our assay results are going to look something similar to this, kind of a dashboard that tells you whether you're in like a green zone, which would provide full protection, or maybe you're not quite at a level that would provide you adequate protection. You might be in a red zone. So this is a relative titer to an average titer from those colostrums and milk replacers. So just if you look at the bars associated with the dashboard, that kind of tells you what level you're at based off of the assay. So we're establishing this relative titer scale. So we're going to be collecting many samples and also both liquid and dry, and then milk replacer samples as well. And we're using this assay then to generate a quantitative number, this relative titer. And then we also want to collect data on the back end too, like where does this colostrum come from? If it's waste milk that's being fed, were these vaccinated cows, or was this pasteurized waste milk that's being fed to their calves? So we want to collect all that extra data. So that's part of the sample submission form, and we'll collect that, and then we can actually partition the data so that you can kind of see each of the comparisons within that sample. And then as we get more data, these relative titers become more and more accurate. So as we get more data to this, it'll become a better and better test. And the potential upgrades in the future is we're going to add more antigens. So we kind of leverage our background in recombinant technology. We're using our strains that we have in-house to develop all of these antigens. So we're taking each one of the bugs, each one of the bacteria, and we're taking the DNA and we're amplifying out and purifying the protein associated with the antibody production. So very similar proteins that would be found in the vaccines, amplifying those out so that we can test for that specific antibody that would be in the milk replacers and colostrum. So a couple examples of additional antigens would be the bovine viral diarrhea virus, and then the bovine respiratory syncytial virus. And then we have different sample types. We want to move into also testing serum, spray-dried plasma, and then whey protein concentrate as well, and then get more of an absolute quantitative measurement at the end. So instead of a relative, we actually get an actual number for you in the future. Whether it's milligrams per milliliter or milligrams per gram of antibodies to colostrum. And we're expecting to launch this service early next year, whether it's quarter 1 or quarter 2. And as far as our current status, right now we're finalizing a lot of these protocols and the specificity assays. We're purifying out the antigens and then testing to make sure that those antigens show specificity and in unique specificity and not any cross-reactivity or anything like that. And then we're establishing the relative titer scales. Okay, and so in summary, like Dr. Jones said, antibodies can only react with specific antigens. And that's the unique nature of this assay. Currently, there's not that much information available on antibody specificity in colostrums and milk replacers and waste milk and then we want to work with calf producers, vets, nutritionists, and these are the people that need this information. And that way they can make knowledgeable health decisions on developing healthy calves. And like initially, we plan on providing these relative titers to these 8 enteric pathogens. And again, we're looking to start offering this early next year into the second quarter. All right, so with that, I'll open it up to questions, and I'll invite Dr. Jones back up here. Sure. The samples will be sent to BTR, and we'll test them in our facility. And we'll have a website that would be set up for the sample submission, and you can fill out the data. If you need help with that, you can call, or we can do it over the phone.
Yeah, question about the samples you will have, those are added colostrum.
Yeah, so the question was the milk replacer samples, they had added colostrum or not added colostrum, correct? No, so that was just the milk replacers by themselves. So it was 5 milk replacers. They were all milk component only, so they had no plasma in them. And so it was just different wave fractions in the milk replacer. That was where the IgG came from.
The milk replacer or colostrum replacer that you tested, will that vary from lot to lot or from certain companies? Is it always the same when you go to test it as far as where it showed on your scale?
I guess that's, so yeah, the question was, is how's it going to compare to lot, and that's a great question, and that's what this service is designed to answer. Because right now, you as the producer don't know. The company, they may know or they may not know. That's the kind of what we hope to answer here is that, again, provide the producer, the vets, nutritionists with more information. Right now, as far as we know, they don't have this information. So it's just to provide them with this information of where their antibody levels are. So we think that's an important need that the industry doesn't have right now.
Yeah. It's ELISA-based, yeah. Yep.
I don't understand exactly. So are we saying that the producer will samples their colostrum because the need for colostrum is so critical. How will they get the results back without
Yeah, so the question was, we would test how fast you get the samples back because the colostrum is important to give. And yes, so we probably can't turn it around at that fast. But it will give you information of basically if you have a vaccination program for your cows and your dams, and kind of if you have this program, you'd expect your colostrum be fairly similar from batch to batch. And this will tell you that. So it would tell you your current program where your antibody levels are, and if there's need for improvements or not. Yeah, it couldn't be real time, unfortunately.
And just to build off what Dr. Jones was saying, this is information that we want, and then you can kind of project like what levels you're at. And there's also data that we can get and collect from vaccinated herds versus unvaccinated herds. And that'll kind of give you kind of a good idea of, or a good approximation of where your antibody levels would be.
And it's also just after the fact, let's say you test a colostrum, you find out like those that you're low on salmonella, then your milk replacer, you have to make up for that somewhere. If they are vulnerable, and that's a challenge, you have to plug that gap with something.
bacteria in the colostrum sample, is that going to vary the antibiotics? When say you get a sample that's way high in bacteria, does that change what you're looking at as far as the antibodies or the antibodies?
Okay.
Or is that bacteria we always see when we have poor bacteria, or we have a lot of bacteria in the colostrum, it changes what it goes to the cap. Does that affect what your test is going to?
Okay, so the question is, will the bacterium in the colostrum affect our test? And it will not. And we would be removing any of those contaminants before we do the testing. So in our test, it wouldn't matter. It could be indicative of maybe a disease that you might be carrying. We can do disease testing in our facility as well, but the way that we're preparing the samples, any background bacteria, viruses would all be filtered out. Can you repeat that? Okay, so I think I got the question. If we want to examine the health that's in the herd. I think you would want to examine whatever you're normally feeding your calves. I think that's where you'd want to start to establish a baseline. And then if you have colostrum, you can have that analyzed as well, so you kind of know that what antibodies and what specificities in your colostrum throughout your herd, And that way you could also supplement if you're using just regular cow's milk or waste milk for the calves. But otherwise, yeah, we could test the colostrum too.
All right.
When you do that testing, are you going to come back with some recommendation as far as what you're finding, as far as how we can do something about it?
Right, yes. So the question is, will we be able to provide a recommendation based off of our assay? We can give you the specificity profile, and then you could either work with a nutritionist or a manufacturer, of a milk replacer or colostrum, or you could, look at EgCel as a supplement as well to make up the difference, to provide that protection.
So one thing I guess we would hope to eventually get to, you see that scale, let's say you're low in this one category, we would then be able to tell you if you add X amount of an IgG or an IgY, how much you have to add to get to that other, to get from like, let's say the bottom 5% to get to the top 10%. We would hopefully have that recommendation. You would have to have X amount of antibodies to get to that level. Eventually we would want to get to that level, but we're not going to, we have to validate, make sure everything is correct first.
So the question is, are we looking to develop a kind of a quick test on the farm? Right now, I mean, that would be ideal. Like if we could just have a dipstick or something like that, that would be fantastic. But right now, the technology doesn't quite allow us to do that. If we can develop a variation of this, we might have like a separate dipstick for each of these pathogens or something like that. So that could be some evolution of this assay.
Mm-hmm.
So we haven't really developed the cost yet. We're still evaluating what that cost is going to be through a number of factors. We're trying to keep costs down by making these proteins in-house. Using recombinant technology will allow us to really drive the price down. And so we don't have a solid number for you yet. I'm sorry.
Yeah, we do know it's going to be, that's important. We do know a producer is going to submit samples. It has to be cost effective. So that is something
Right.
We're trying to minimize the cost as much as possible.
When you do get this all set in place, how is that going to be out to find out about the availability of getting that, starting that test? How are we going to know when you're going to be doing starting to be able to allow to take samples and how we handle samples? What kind of information are you going to get out to know when this is all going to come about?
To be determined, but probably through press releases. We'll probably try to get the word out. There'll probably be a soft launch in a way to work with a few companies to make sure we have everything done, and then it'll be a big launch. That's to be determined how we'll get the word out, but this is part of the effort of letting the community know this is coming out hopefully early next year, and we'll inform you of when it's ready. But the marketing campaign is still in the works. All right, I think there's no more questions. We'll go ahead and...
Yep. Thanks, everyone.
Thank you for your time.